Okay. So see, oh, Nida is also here today. क्या हो गया भाई आज सब आ रहे हैं? अस्सलाम वालेकुम निदा, हाउ आर यू?
Walaikum assalam. I'm good, alhamdulillah.
Fine. Okay. What happened after a very long time?
I was actually on a vacation.
वेकेशन तो पढ़ाई से आपने वेकेशन ले लिया? आपको स्कूल से ना वेकेशन मिला था? राइट निदा?
Yes,
So your vacation is over now?
yes,
Okay. And like, were you in touch with the recordings?
yes, some of it.
Some of it. काम नहीं चलेगा ऐसे, ठीक है? फिर मार्क्स आप लोग के नहीं आएंगे, है ना? ठीक है, तो ध्यान रखिए इन सब चीजों का। एकदम बिल्कुल ही सही नहीं है इस तरह से एब्सेंट करना, ठीक है? And then you don't even watch. If you don't even watch the lecture, then it is going to be real bad. Okay. When is your exam, Nida?
They actually cancelled our exams to
Okay,
complete the portion.
you're in Riyaz or Dammam?
Riyadh.
और रियाज वाला, हाँ, उन लोगों ने कैंसिल कर दिया, दैट्स ट्रू. Okay, fine. Did you watch the last lecture?
No.
Okay. Atif, what about Atif? Sorry, Aisha, how are you? I can't hear you, Aisha. Aisha, you are not audible. Okay. So just to revise, like from the previous class, let me see what are the questions I have given you guys. So I can give you some new questions here. Okay. Fine. So I can give you some new questions. Represent the cell. In which following reaction happens. So Nida and Hiba, both of you are in the same school, I think, right? Yes, Nida?
I don't know.
You don't know?
No. I study in International Indian School.
International Indian School Riyaz. She also studies in International Indian School Riyaz. आप स्कूल जाती हैं या स्कूल में नहीं जाती हैं आप?
No, it's online currently.
Online?
Yes.
क्यों? कोरोना हो रहा है वहाँ?
There's actually transportation problem.
Transportation problem. Okay. Some construction is going on. It's hybrid kind of thing. So you don't go to the school?
No.
When was the last time you went to school?
Before vacation.
Before vacation, like regularly या फिर?
Regularly.
Regularly. Okay. And how is your health? Is it better now?
Yes, alhamdulillah.
Okay. Also, Atif, any doubts with the marks? Tell me. Yes, Atif?
No, sir.
Okay.
So we should send the answer or not required?
No, send the answer. Please send the answers. Yeah, those are correct. Yes, correct. So we write the cell like this, A, B, C. This is just a mnemonic and this is just a handy tool to remember that we write the anode first. Oxidation happens in anode. Then we have a bridge, and then in cathode, we write the reduction, Mg2 plus, which is changing to Mg. Now here also, the oxidation is happening for HAG. So I will start with HAG, which is getting converted to Hg2 plus. There's a bridge, and then we have Ag plus to Ag. Okay. Now, I want all of you to go to the page number 71 of your NCERT textbook if you have it. Much better. If not, then I'm going to paste something.
So what's the page number?
71. You must see a very big table like this. Okay, so I hope all of you can see that. If not in your textbook, then in the screen here. Okay, all of you can see here. Okay, Atif, can you please read the first reaction what they have given? Can you read it out loud, Atif? Fluorine plus.
Yes, sir. Fluorine plus 2 electrons gives 2 fluorine minus ion.
Okay, fine, very good. Now, is this a reduction or an oxidation? Please tell me, guys, in the chat, oxidation or reduction, what is happening here? Please tell in the chat what is happening here. Oxidation is happening or reduction is happening? Fluorine is gaining electron or losing electron? Yes, correct, Krishna. Correct, Atif. Yes, very good, Neda. Correct. Oxidation is happening or reduction is happening? Waiting for Hamza, Heba, Aisha. Please tell me, guys, reduction or oxidation, what is happening? Fluorine is gaining, then it is reduction. If it is losing electron, then it is oxidation. I'm not getting answers. If you're sending it, you're sending somewhere else. Hamza, Heba, please send the answers. Hamza, Heba, and Aisha. Correct, Hamza. Heba, waiting for you. And Aisha, waiting for you. Fe2. Yes, correct. Aisha, I don't know whether you are here or not. Yes, correct. All of you right. Okay. Now, that's very good. All of you identified that. It is what? It is a reduction. What about the next one? Tell me, guys. What about the next one? Oxidation or reduction? What about the next one, guys? Please tell me. Oxidation or reduction? Correct. You can just write R or O. You don't need to write the full word. It would be much faster. Yes, correct, Atif. Correct, Neta. Very good. Right. Okay, fine. Now I'm scrolling down. Look at anywhere. What do you see? Look at any of the reactions. What do you see? Any reaction? What do you see? Please answer in the chat. Any reaction? What is given here? Look at any reaction. Right? So all of these are what? All of these are reduction reactions. All of these are reduction reactions. And now we have the voltages here, right? The potential. So all of these are reduction potentials. All of these are reduction potential. And since IUPAC has said that reduction potential, we are going to call them in general as electrode potential. So they have also written it as E0 here. They have also written it as E0. Okay, fine. Now tell me, I'm writing two things here. Okay, I'm writing two things here. Let us suppose you have went and you have gone to buy a battery. You have gone and you went to Lulu and to buy a battery, or we can call it a cell also, right? Batteries, small batteries are known as cell also. And you saw a battery which has written 5 volts. This is battery A. And there is another battery which has written minus 5 volts. There is another thing I would say, I would not say it is a battery, but minus 5 volts. So tell me which one of them is a battery, 5 volts one or minus 5 volts? Which is a battery? Battery would have a sign plus 5 volts or minus 5 volts. Tell me, guys. All of you, please tell me. Okay, I hope it is. I hope that you have seen that voltages are given in batteries, right? 5 volts or something, 6 volts, 10 volt, 8 volt battery, 10 volt battery, something like that. Okay. Now, that means any cell that is going to give you electricity, it will have a positive volt. Yes or no? Please tell me, guys. Any cell which is going to give me electricity, it is going to have what kind of volt, positive or negative? Please tell me.
Positive.
Positive volts, right? It will have positive volts. That means this reaction here, the fluorine reaction here, it is giving me electricity or it is taking electricity? Tell me, guys. This fluorine one, it is giving electricity or taking electricity? What did you say, Atif? Can you please repeat that for everyone?
Giving electricity.
Very good. Can all of you see that it is giving electricity? Yes or no? Please tell me. I don't think you will have any doubt. Cells, they give electricity and we write them as positive volts. Okay. That means this reaction is what? It is spontaneous because it is giving me electricity. Any spontaneous reaction is only capable of giving me electricity. Is that clear? Yes or no? Please tell me, guys. Can I get a yes or no, sir, from everyone?
Yes, sir.
From everyone, please. This is
Yes,
very
sir.
crucial, actually. Yes. What about others? Hamza, Hiba, Nida? Yes. Okay, fine. Great. Now, if I go down, and also, I hope you can see that it is a bit logical also, right? Because fluorine, what do you think? It has a tendency to lose electron or gain electron? Fluorine, which is so electronegative, it has a tendency to lose electron or gain electron. Tell me,
Lose
guys.
electron.
अरे lose, it will gain electron, ना कृष्णा? Electronegative वो तो खींचेगा ना electron को.
Yes, sir.
Clear है? Right?
Yes.
Clear, na, Krishna? I'm not imposing anything, right? I don't want to impose anything here, okay? So fluorine has what? Tendency to gain electron. And also you can see it is gaining electron, it is spontaneous and it is giving me electricity. Anything which is spontaneous, only that thing can give me electricity. Water falling from a height from a dam, that is a spontaneous change. That is happening automatically, right? Automatically in the sense without the interference of a human being. Human being has nothing to do with water falling from the dam. And that is why we can generate electricity from there. Similarly, fluorine has, like fluorine, which is getting converted to fluorine negative, it does not need any human effort. It will happen automatically. So it is giving me some electricity. But if I go down, and I look at the metals here, can you see lithium? Lithium is what? Lithium is a metal, right? And if lithium positive is eating electron, that means if lithium positive is gaining electron, it is quite inconvenient for lithium. Lithium does not gain electron on its own. Human has to give. Now this negative sign, what is it? What does it denote? Like a battery having minus volts, negative volts, it does not make sense. No battery will have minus volts, right? Negative volts. That means this reaction, which has a negative volts, it needs 3.05 volts of electricity in order to happen. In order for this reaction to happen, we have to give energy now. We have to give electricity. Is that clear? Yes or no? Please tell me, guys.
Yes,
Is that
sir.
clear? Okay, fine. Now, I'm going to take zinc that we have used very extensively, and I'm going to take copper. Okay, zinc and copper. Okay, so we'll first of all write like this. Zinc 2 plus 2 electron is giving me zinc. This is the reaction they have given, and this will give me electricity, or it requires electricity. Please tell me. Looking at the board, like looking at the screen here, this reaction, it needs electricity, or it will give me electricity.
It needs
Needs
electricity.
electricity.
Needs electricity. So I will write the E naught for this reaction, that is E naught reduction, because reduction is happening. E naught reduction for this reaction is what? How much? Minus 0.76, right? Volts. 76 only, no? 76 volts, yeah. Then we have the copper one. Copper 2 plus 2 electron is giving me copper. This E naught reduction, it needs electricity, or it will give me electricity? Tell me. The copper one needs, or will give me electricity?
Gives.
It gives electricity, right? Can all of you see that? Yes or no? Please tell me. Yes, Atif, Nida, Hamza, Hiba. Can I please get a yes or no, sir? Those who can speak, please speak. I cannot open the chat always, है ना? Those who can speak, those can turn the mic on. Please speak. Okay, plus 0.34 volts. Very good. Okay, now that means whose reduction will happen automatically? Copper or zinc? Whose reduction will happen spontaneously? Copper or zinc?
Copper.
Copper. And if the reduction of zinc is non-spontaneous, then the reverse will be spontaneous. That means if I have zinc, then it will spontaneously give me zinc 2 plus plus 2 electron. And for this E naught, now I am going to write oxidation. It is going to be what? Plus 0.76 volts. Is that clear? Yes or no? Please tell me, guys.
Yes, sir.
Yes.
Right? No problem. Okay, fine. Now, I have both the things written and both the things are spontaneous now. Now I am perfectly capable of making a cell. I'm perfectly comfortable for making a cell. Now you guys tell me, copper wants to get oxidized or reduced? Copper wants to get oxidized or reduced? Tell me. Copper wants to get oxidized or reduced?
Reduce.
Reduced. And zinc wants to get? Zinc wants to
Oxidize.
Okay, fine. And if I have to make electrochemical cell, we need two things. We need an anode. We need a cathode. Now tell me, what do you think will be the anode, zinc or copper? What happens at anode? Zinc. Very good. Because what happens at anode?
Oxidation.
Very good. And also you'll write the sign like this. Zinc to zinc 2 plus. Right? For cathode, what I will write? Cu2 plus to Cu. Got it? Yes or no? Please tell me.
Yes, sir.
All of you? Okay, fine. Now, when zinc is getting converted to zinc 2 plus, it is giving me electron or taking electron? Once again, it is giving electron or taking electron?
Giving electron.
Giving electrons. नहीं, sorry. Giving electricity. My bad. It is giving electricity. I hope you understood the feeling. है ना? शब्दों पे आप नहीं गए, आप मेरे जज्बातों पे गए. Thank you very much. So zinc is also, it is giving electron. That is why I think you said, okay, fine. It is giving electricity. How much electricity? Zinc is giving how much electricity for this reaction? How many volts of electricity? Very good. 0.76 volts. And the copper guy is giving how many?
0.34.
That means if I have a cell for this, I will just add a bridge. Now it is a cell. The E naught of cell will be equal to how much? I will get 0.76 volts of energy from anode, and I will get 0.34 volts of energy from cathode. This will be equal to 1.10 volts of energy. Is that right? Yes or no? Please tell me. Yes, everyone?
Yes, sir.
Please tell me, right? How many of you have done electrochemistry, this part in school?
I have done, sir.
You have done. Confusion नहीं है कोई आपको? क्योंकि स्कूल में थोड़ा सा तो दूसरा कराया होगा उन लोगों ने.
No, sir, no.
Okay, fine. ठीक है. That means I can write E naught cell as the E naught of oxidation for the anode plus the E naught of reduction, and that is whatever is in the cathode. As simple as that. Is that clear, guys? Yes or no? Please tell me.
Yes, sir.
Okay, fine. Now I'm going to write some things. Please write oxidation potential. Please write the tendency of an electrode to lose electron or to get oxidized is called oxidation potential. Next line. Higher the value of oxidation potential, higher is the tendency to lose electron or to get oxidized. Reduction potential, the tendency of an electrode to what, lose or gain electron, you will write it, fill in the blanks, or to get dash is called reduction potential. Higher the value of Rp, higher is the tendency to dash electron or to get dashed. All of you wrote this, can you please tell me?
Yes, sir.
I hope you have filled in the blanks also. Those who have not, so here you will have electrode to gain electron or to get reduced. Same things you are going to fill here. Gain electron or to get reduced. Tendency of an electrode is electron or to get to reduction potential. Hide the value of the gain electron. Okay, fine. Hide the next point. Galvanic cell consists of two half cells. Okay. The half cell having higher reduction potential. I will write higher oxidation potential first. Oxidation potential. Higher oxidation potential acts as anode, and the half cell having higher reduction potential acts as cathode. Everything makes sense till now? Any doubts, please let me know, because I think I have explained everything. I'm just writing those points. आतिफ, कृष्णा, हमजा, हेबा, निदा, नहीं निदा, अगर आप लोग तो एक रिकॉर्डिंग देखिएगा तब जाके ज्यादा समझ में आएगा. But you guys tell me, आतिफ, कृष्णा.
Yes, understood.
Understood, ना? Okay. Right, next. EMF or cell potential. EMF or cell potential. Please write the potential difference between electrode potential of between the two electrodes, between the two electrodes in a electrochemical cell. Okay, write some remarks. Number one, EMF is defined as sum of electrode potential of oxidation and reduction half cells. Okay, so wherever oxidation is happening, oxidation and reduction half cell, wherever oxidation is happening, and we will take the oxidation potential. Wherever reduction is happening, we'll take the reduction potential. Okay, so if we have E naught cell, this will be equal to E naught of oxidation. Oxidation happens at anode plus E naught of reduction. Reduction happens at cathode. But if we don't have it in standard conditions, then E cell will be equal to E of oxidation. Oxidation happens at anode, and E of reduction. Reduction happens at cathode. Okay. Now, next point. Since IUPAC considers reduction potential as the electrode potential, the above equation can be written as. So what I'm going to take the E naught reduction for everything. So E naught cell, for both the half cell, I'm going to write the E naught reduction only. So E naught oxidation of anode. Okay, please listen here. Please stop writing. Please stop writing and please listen here. E naught cell for oxidation. If I want to write the reduction for this, then what I will write? I'm going to write it minus E naught reduction of anode. Yes or no? Please tell me, guys. E naught oxidation is equal to E naught reduction. Yes or no? All of you agree with this? Okay. Plus, here we have reduction only, so we don't need to change it. So this will be E naught reduction of the cathode. Now I can write this simply as E naught of the cathode minus E naught of the anode. Okay, but please remember here, this and this both are reduction potentials. Similarly, for E cell, I can write E of cathode minus E of anode. ये आपका standard reduction potential लिख दीजिए यहाँ पे SRP, and here the E's are the reduction potential which are non-standard. But please remember, this cathode minus anode is a derived thing. It is not the original thing. Okay. So simple basic logic dictates that whatever energy I'm going to get from the oxidation half plus whatever energy I'm going to get from the reduction half, that should be my E cell or E naught cell if you are taking the standard case. But since IUPAC considers the electrode potential and it can, by convention, it has the reduction potential as the electrode potential. So generally electrode potential are given in reduction potential, and we have to change the formula to this form, E naught cathode minus E naught anode. Okay. But I still would recommend you to use this one because it will be helpful when you are seeing the reaction, and I will show you how. Okay, when you have been given a reaction in that case, and when you are representing a cell in that case, all of these cases, it will be helpful. Please tell me if you have written all of this. Yes or no, please tell me. Is everyone done writing this?
Yes.
Yes, sir.
Okay. Now, rather than question, just see here. Okay. So tell me for the first one, what is happening? Oxidation or reduction here? Please tell me, guys, what is happening here? Oxidation or reduction?
Reduction.
Okay. What about here?
Reduction.
What about here? Hg, please tell me, guys. Hg. What about here, in here, everywhere? What is happening? Oxidation or reduction? Reduction. Nida, can you get this? Oxidation. Nida, tell me. Can you see why it is oxidation? Why they are saying reduction? Yes, Nida? Answer me no. Okay, fine. Nida, can you please turn your mic on? What is this? Oxidation or reduction? Nida, please turn your mic on. Keep your mic. Reduction. So this whole thing, we can write it like this. Got it? This is how we can represent it. Got it, Nida? Okay. Fine. So this is going to be, all of these are reduction. Okay. Nida, can you tell me this reaction, it will give me electricity or it will take electricity? What do you think? This reduction here, it is going to take electricity or it is going to give me electricity? It will give me electricity or it will take electricity? Yes, Nida?
Give electricity.
It will give electricity?
Yes.
Okay, that means you will buy a battery in which they have written it is going to give you -5 volts. Will you buy a battery like that? Tell me, Nida.
No.
No. So it will give electricity or take electricity? Take electricity. ठीक है? Please इसको ध्यान रखिएगा. I know that most of your people give and take में आपको दिक्कत इस वजह से हो रही है because of the energy concept, right? Because when it is negative, it is exothermic, it gives energy. That's the reason you are having this problem. A bit of confusion that you are having, Nida and others, those who had actually. Nida को अभी आया ये confusion. Was it because of that? Krishna, Atif, Nida?
Yes.
Yes, but again, please remember these are all battery. ठीक है? तो please ध्यान में इसको क्या रखिए? These are all battery, and you have to treat it them as battery. So you will never buy a battery who's giving you -2.93 volts of energy. Okay, so obviously this reaction, that means, okay, this reaction is going to take electricity or it is going to give me electricity. Please tell me, guys. Once again, all of you, please turn your mic on and tell me. It is going to give electricity or take electricity?
Take electricity.
Take electricity. Very good. That means it will be spontaneous or non-spontaneous. Spontaneous or non-spontaneous? If it is going to take electricity?
Non-spontaneous.
Non-spontaneous. Very good. So this reduction is going to be non-spontaneous, right? What is happening here? Reduction? What happened?
Yes, sir.
Nobody is answering. Atif, Nida, please answer, na? Please answer, please. Now, if the reduction is non-spontaneous, the oxidation will be? Spontaneous. Okay. Now here tell me, spontaneous or non-spontaneous? Ag plus 2Ag? Spontaneous? Spontaneous. Okay, Cr3 plus 2Cr, spontaneous, non-spontaneous?
Non-spontaneous.
Non-spontaneous.
Mg2 plus 2Mg, spontaneous, non-spontaneous?
Non-spontaneous.
Non-spontaneous. This Hg2 plus 2Hg will give me electricity or it will take electricity?
Give electricity.
Give electricity. Very good. Okay. Now tell me, this Ag plus 2Ag, if you have been given just this one, Ag plus 2Ag, you will put it in anode or cathode? Where will you put it? Anode or cathode? Okay. First of all, tell me what is happening here. Oxidation, reduction?
Reduction.
Reduction. Spontaneous, non-spontaneous reduction?
Spontaneous.
Spontaneous reduction. And if it is spontaneous reduction, where will you keep it? Anode or cathode?
Cathode.
What about this one? आया आतिफ आपको कैथोड में क्यों आएगा? Yes, Atif? Your mic is off, Atif.
Yes, sir.
You got why this will be in cathode?
Yes, sir. I got it. Understood.
Got it? Okay. Makes sense. Okay, fine. What about this one? Where will you keep this? Anode or cathode?
Anode.
What about others? Please tell me. Answer
Anode.
in the chat. Okay, fine. What about this guy? Anode or cathode? Where will you keep it?
Cathode.
Cathode. Now, like with this information about the volts, I think, can you see what are the hidden information that you can have? Tell me, guys. Like this information is also giving me which should be the anode, which should be cathode. Now what I'm going to do, I'm going to change the scenario now. Okay, I'm going to change the scenario. Let us suppose I'm going to take only these two. Which one will you keep in the anode? Tell me. And which in the cathode?
What is
this red one? Tell me. Out of these two, I've taken Mg and Cr. I want to make a cell using Mg, magnesium, and chromium. What do you think? Which will be in anode and which will be in cathode? Where will you keep? Which one? अरे हमजा
Mg2 + Mg.
हाँ हम पूछते हैं which will, अच्छा ये बताइए एनोड में किसको रखिएगा? What will be in anode? Tell me guys. हमजा एक कैथोड होगा तभी तो सेल बनेगा. Mg. What about Krishna? Confused Krishna?
Yes, sir.
Okay, fine. ठीक है, देखिए कंफ्यूजन हटाने के लिए नेगेटिव इस वजह से कंफ्यूजन हो रही है. Okay, all of you please see. It is negative. That is why confusion is happening. If I write Mg to Mg2 plus, then this will be equal to how many volts?
2.37.
Plus 2.37. And if I write Cr to Cr3 plus, then this will be equal to how many volts?
0.74.
Plus 0.74. What do you think? Who is dying to get oxidized? Who is dying to get oxidized? Who is going to give me more electricity when I'm oxidizing it?
Mg.
All of you can see that, yes or no? Please tell me. Hamza, Nida, can all of you see that? Which of them is going to give me more electricity if I'm going to put it in anode? It is going to be Mg, right? Yes or no? Please tell me.
Yes, sir.
Okay, so evidently that chromium is going to be in the cathode, right? So now please see A, B, and C. What should I write in anode? I will write simply Mg upon Mg2 plus. There will be a bridge. What should I write for cathode? Please tell me, Krishna.
Cr.
What should I write? नहीं पूरा बताइए सही से.
Cr3 plus slash Cr.
Very good. Cr3 plus slash Cr, because it should represent the reduction here. Okay, it should represent the reduction. निदा समझ में आ रहा है आपको?
Yes, a little bit.
हाँ, तो पूरा समझने के लिए क्या करना पड़ेगा निदा? So please watch the video, okay, and then revisit. Watch this video once again, then you will understand. Okay, fine. Now all of you will tell me this reaction Mg to Mg2 plus, it is going to give me how much electricity?
2.37.
Like please answer in plus and minus. Okay, like make this a habit. I mean 2.37 is not wrong, but again, it's better to say. It's better to say a root 2 rather than saying root 2a. है ना? All of you agree?
Yes.
है ना?
Yes, sir.
इसी तरह से it's better to have the signs in touch. Okay, so 2.37. Okay, and this reaction is going to what? Tell me.
Minus 0.74.
Can all of you see that? Please tell
Yes,
me yes
sir.
or no. Minus 0.74. When I will make a cell like this, then this cell in total is going to give me how much electricity? It will be 22.37 minus 0.74 ना? Yes or no? क्या वैल्यू होगा इसका बताइए? 7 minus 4 is
1.63.
1.63. 63. ठीक है. Volts. अच्छा. Now, can you see that without even having a formula, we can do these problems? Yes or no? Please tell me. E0 सेल का जो अगर आप लोगों ने मतलब अगर स्कूल में पढ़ा है तो फॉर्मूला वगैरह होगा, लेकिन बिना फॉर्मूला के भी लॉजिकली स्पीकिंग वी कैन गेट द पर्टिकुलर आंसर. यस और नो?
Yes, sir.
है ना? सो ट्राई टू हैव अ इंट्यूशन फॉर दैट. ओके, व्हाट इज हैपनिंग नाउ? आई होप एवरीथिंग इज क्वाइट लॉजिकल and you can reach up to at least E0 cell very logically without even remembering any form. Okay, so if you have a unconscious competence, that means like you are going to give the answer without having any knowledge of the, even if you don't know the formula and all. So that is better. सिर्फ formula apply करने से कुछ नहीं है. If you know it, how it is happening, why it is happening, that is more better. Okay, now let us choose another case. Let us choose this case here, K plus and Hg. So guys, tell me. Tell me guys, what should be in anode, what should be in cathode? K or Hg? Anode में क्या होना चाहिए? What should be in anode? Tell me that. K or Hg, which should be in anode?
K.
Hamza, confused? Hamza?
K.
Okay. Hamza, can you, like, is there any possibility that you can turn your mic on? Is there any possibility that I can hear your voice? Hamza, do you have your phone, Hamza?
Sir, can you hear me?
Arey wah, I can hear you. Yeah, after a very long time. I think it has been months since your mic was off. Okay, so tell me, what comes in your head when I say anode?
Sir, oxidation.
Very good, very good. Now, what do you think? Where is oxidation happening and where it is spontaneous? Potassium or mercury?
The mercury.
What is happening in mercury?
Sir, it is spontaneous.
No, नहीं वो नहीं पूछ रहे हैं. एनोड में क्या होना चाहिए? ऑक्सीडेशन स्पॉन्टेनियस होना चाहिए, राइट? बोथ द थिंग्स शुड बी देयर ना, हमजा?
Yes.
एनोड में क्या होना चाहिए हमजा? व्हाट शुड हैपन इन एनोड?
The polarity should be negative.
अरे मारेंगे आपको। ये पोलैरिटी है, ऑक्सीडेशन रिडक्शन से किसी का कुछ लेना देना नहीं है पोलैरिटी का, ठीक है? एक तो ये चीज को एकदम बिल्कुल खिड़की दरवाजे सबसे बाहर निकाल के फेंकिए आप लोग, ओके? नेवर रिमेंबर द पोलैरिटी अकॉर्डिंग टू ऑक्सीडेशन रिडक्शन. Only anode and oxidation are related to each other. The polarity depends where the electron is. अभी दूसरा सेल पढ़ाएंगे उसमें सब कुछ उल्टा हो जाएगा, फिर आप लोग बोलिएगा सर ऐसा क्यों हो रहा है. So the polarity is a consequence of oxidation. It is not related directly to oxidation. Okay, please remember this, guys. Oxidation, reduction, and polarities, these are not related. What is related? Anode and oxidation are always related. Whenever you have anode, there will be. Whenever you have anode, there will be what?
Oxidation.
Oxidation. ठीक है? Now tell me. अच्छा, oxidation should be spontaneous oxidation ना हमजा?
Yes, sir.
ठीक है. Hg का क्या हो रहा है? What is given here for Hg? What is happening in Hg? Oxidation or reduction?
Reduction.
And reduction is spontaneous, non-spontaneous? Reduction of Hg, it is giving me electricity or not giving me electricity? Tell me. Hg is giving me electricity. The reduction of Hg is giving me electricity or not giving me electricity, Hamza? Or is it taking electricity? Tell me.
Sir, taking.
कैसे पता करते हैं बताइए जरा. सिंपल रूल्स हैं बिल्कुल. बैटरी आपको क्या करेगा? वोल्ट्स पॉजिटिव में देगा, नेगेटिव में देगा बैटरी हमजा?
The positive.
पॉजिटिव में देगा. पॉजिटिव में दे रहा है यानी कि क्या हो रहा है? स्पॉन्टेनियस हो रहा है ना, अपने आप से दे रहा है. करेक्ट. बैटरी को तो अलग से बैटरी की जरूरत नहीं होती ना, बैटरी तो देता है इलेक्ट्रिसिटी बिना ह्यूमन के एफर्ट के, है ना? सही है, ठीक है. अब बताइए आप, Hg जो है यहाँ पे, इट विल गिव मी इलेक्ट्रिसिटी. द रिडक्शन ऑफ Hg विल गिव मी इलेक्ट्रिसिटी और इट विल टेक इलेक्ट्रिसिटी.
The give.
पक्की बात
Yes, sir.
है ना? नाउ if the reduction is giving me electricity, the oxidation will. If the reduction is giving electricity, the oxidation will give or take.
The take.
ठीक है. So can I put it in anode? Can I put Hg in anode? Tell me.
No, sir.
No. What about potassium? What do you think? What is happening in potassium here? What is given? Oxidation or reduction? Sign को मत देखिए. जब भी हम oxidate, whenever I'm asking, this is like I will scold you guys. If you look at the sign, when I ask you guys about oxidation or reduction, when I ask you guys about oxidation and reduction, your focus should be only here. No matter what this is, I don't care about it right now. When I'm asking oxidation, then what you have to look? You have to look at this portion here. Okay, guys. Now tell me, what is happening? What is given? Oxidation or reduction? What is given? Oxidation or reduction? Hamza, you should not be struggling here. Others, please answer in chat. Hamza, what do you think? What is happening for K plus to K? Oxidation or reduction?
The reduction.
पक्की बात ना? आपको इतना देर लग रहा है हमजा? स्कूल में पढ़ाना चालू कर दिया क्या इन लोगों ने इलेक्ट्रोकेमिस्ट्री?
No, sir.
नहीं ना, फिर भी आप क्यों इतना कंफ्यूज हो रहे हैं? चलिए, यहाँ पे क्या हो रहा है बताइए आप. Ag to Ag प्लस में
The reduction.
आप तो पहले सब सही से ही बता रहे थे, अभी भी सही से बता रहे हैं. ठीक है. K प्लस टू K में आपने बोला क्या हो रहा है? रिडक्शन हो रहा है. और रिडक्शन इज क्या है? स्पॉन्टेनियस एंड नॉन स्पॉन्टेनियस. नाउ व्हेन आई आस्क अबाउट स्पॉन्टेनियस नॉन स्पॉन्टेनियस, व्हाट यू हैव टू सी? दिस पार्ट. टेल मी हमजा. Spontaneous, non-spontaneous. It will give electricity or take electricity?
It's a non-spontaneous.
Non-spontaneous, right? So reduction is spontaneous or non-spontaneous, Hamza? The reduction of potassium is
It's a non-spontaneous.
So the oxidation will be
Spontaneous.
very good. If it is spontaneous oxidation, then I will put it at anode या cathode.
Anode.
आ रहा समझ में?
Yes, sir.
ठीक है, एक और लेते हैं. Okay, so our aim is that without moving pen, just looking at the values, we should be able to tell what should be anode, what should be cathode. Now here tell me, Hamza, if I take Ag plus, if I take Ag and chromium, which one should be at anode? First of all, start with a very simple case that I have to take the one whose oxidation potential is higher. Or you can rather write it also as, or the reduction potential is lower. Others can answer in the chat. Yes, Hamza, tell me.
The Ag will be in cathode
Okay.
and chromium will be in anode.
समझ में आ रहा है आपको या फिर मतलब कुछ दूसरे तरीके से बोल रहे हैं?
No, sir, I understood it.
समझ में आ रहा है ना?
Yes, sir.
सेंस बन रहा है कि नहीं बन रहा है, ये बताइए आप.
Yes, sir. Actually, when you asked me, I got a little mixed up. So that's why I
अब
got.
ठीक है सब?
Yes, sir.
हाँ चलिए ठीक है सब. Okay. Like the important thing is that Krishna, Atif, tell me guys, make sense everything?
Yes, sir.
Okay, fine. Now what I want you to do is that you have to give me, I will give you some time. I've made a few cells from the data that we have, right? Yes or no, please tell me. You can choose any two. ठीक है? हमजा आप किसी दो को चूज कीजिए, बताइए. Choose any two, Hamza, from here.
Sir, Hg and Mg.
Hg and Mg, right? Tell me what is going to be the oxidation, what is going to be the anode?
Sir, Mg.
And the cathode will be?
Hg.
Hg. You can write the cell. All of you, yes or no, please tell me.
Yes, sir.
Yes, okay. And similarly, you can write the reaction at anode and the reaction at cathode. Yes or no?
Yes.
And similarly, you can also calculate the E naught of the cell. What will be the electricity given by the cell?
Yes.
Right?
Yes.
So please do that. You have all of these things. Just start like making cells, new cells. And I'm giving you 10 minutes. Like in 10 minutes, you like send me whatever, how many cells you can make, okay? From the values here. Okay, or not only cells, okay? Please, I'm writing here. You have to, cell representation you have to show. You have to show cell representation. Next thing you have to show is the cell reaction at anode and cathode. Like with cell representation only, now you can also write and E naught of cell, the EMF. Third thing is cell reaction. Krishna, is this going on in your school, electrochemistry?
Yes, sir. So, but we haven't covered this part yet.
अच्छा अभी स्टार्ट ही है. व्हाट अबाउट यू आतिफ? आई थिंक आपके स्कूल में हो गया ये पार्ट.
Yes, sir. So
अच्छा इलेक्ट्रोकेमिस्ट्री चैप्टर इज ओनली होगा. कृष्णा, हाउ मच हिंदी कैन यू अंडरस्टैंड?
So I can understand Hindi, but I cannot speak fluently.
अच्छा, you can understand, but okay. So if I say निगाहें, what does निगाहें mean? Krishna?
So not that much, sir.
Not that much. Okay, fine.
So I think it is um, sight or something. I think seeing.
हाँ ठीक है, yeah, correct, correct. You know enough. You know enough to remember the electrochemical series. That's why I was asking. Okay. Like for electrochemical series, we have a trick, but that is in Hindi actually. I was seeing that how much of Hindi can you understand?
So I have a doubt between AG and HG.
AG and HG, क्या doubt है इसमें? बताइए. Who is happy to get reduced? Yes, Krishna.
So HG.
Who is happy to get reduced?
Oh, so yeah, AG.
Now you can do it, right? Yes, Krishna. Now you can do it.
Yes, I'll try.
Like there is no difficulty. Okay, just like keep in mind that you have proper representation and all. Okay, you have taken in anode the thing which is getting oxidized easily, and in the cathode you're taking that which is getting reduced easily. Comparatively speaking, okay, always there will be a comparison. There is nothing absolute in the electrochemistry thing here.
So they can be negative anywhere, right?
It can be negative, positive anywhere, but what you have to see is which of them is getting oxidized, relatively speaking, if whose oxidation potential is higher and whose reduction potential is higher. If someone's oxidation potential is higher, then it is going to be higher than the other, and it is going to be in the anode. If its reduction potential is higher, then it is going to be in the cathode.
Okay.
Okay, so guys, please start sending the answers now. I think it's quite time. Anything in the first week. Start sending the answers.
अरे what happened guys? Start sending the answers. एक दो बनाया, जो बनाया आप लोगों ने भेज दीजिए प्लीज. Okay, very thank you Atif. Oh, made quite lot. Okay, so K plus and 80. Yeah, that is fine. That's fine. Correct. Okay. Okay. And Mg and Hg. Very good. Nice choice, by the way, so that you don't have to balance the electrons. And third case, yeah. It's good. You have taken care of everything, I think. Yes, I think so. And then you have with the fourth one also, which is Hg and Ag. Minus 0.9 plus 0.80. Okay, yeah, correct. 0.0. So I mean, it's not giving me any kind of like very little energy, but it's still giving me some volts, so I can call it a battery or a cell. Okay, so Hg. Yeah, correct. Very good, Atif. Okay, so Krishna, Hamza, Heba, please send the answers. Okay, Hamza and Heba, please send the answers. 37 and minus. Okay, fine. This we have taken for Mg, right? Okay. Fine. Okay, fine. So okay, fine. So Krishna has done what? Krishna has taken he has not calculated. I would say he has written everything like oxidation potential, reduction potential, oxidation potential, reduction potential, everything, and then he has chosen. That's quite good actually, Krishna. It gives you a more control, right? There is nothing you have to not depend on your brain. Everything's there in your notebook, and you can easily just okay, this is oxidation hoga, iske yahan pe reduction hoga. That's fine. So your answers, let me check your answers by the way. K plus is fine. The Mg and Cr is fine. K plus and Hg is also good. Mg and Hg. Mg and Hg is also, yeah, correct. And K plus and Cr, yeah, correct. Fine, very good. Oh, you have more. That's impressive. So you have done half. Very good. Hg and Ag have done it correctly. Mg and Ag, correct. Very good. Okay, Hamza, let me see. Mg and Hg. Hamza, why did you write? Hamza, can you please turn your mic on?
Yes.
You have written minus 2.37. It will be plus, na?
Sir, I made the
You have,
change in the next
you have made the change, but I'm just wanted to confirm.
Exactly.
Whatever value, but like write the value for this Mg to Mg2 plus, okay?
Okay.
Otherwise, it may lead to some error maybe later on. K plus में you have, oh fine. सब में आपने ऐसे किया, हमको माइनस देख के थोड़ा सा ये हो जा रहा है, फिर उसके बाद हम देख रहे तो फिर हमको रिलीफ मिल रहा है. ओके फाइन, ठीक है. And okay, so next one, Heba, you also please send me, Heba, Mg and Cr. But that is not right, Hamza. आप प्लीज इसको इस तरह से लिखिए, ठीक है? ओके हमजा,
Yes, sir. I'm right.
है ना? ओके. Hiba, waiting for you. Okay, so that's it actually for today. Hiba, just waiting for you. Can you please send the answer fast? In the next class, we'll learn about the electrochemical series. And its applications. Okay, in the next class, we'll learn about the electrochemical series and its application.
Heba, why are you not sending